When it comes to precision engine work, sometimes the most critical measurement is the one you can't even see. Well, today, we're going to master the exact tool for that job, the bore gauge. We are going to take you from maybe a little confused to totally confident in just a few minutes.
I mean, that's the million-dollar question, right? You need to measure the inside of a cylinder down to a tenth. We're talking 1/10,000th of an inch. Your trusty calipers, as good as they are, they just aren't going to cut it for this job. You need a tool that can reach in there and feel that hidden surface with incredible accuracy.
So, here's our game plan for today. First, we'll tackle the why. Then we'll break down the tool itself piece by piece. After that, it's all hands-on, assembly, calibration, the actual measuring technique, and finally, figuring out what the heck the dial is telling you. Let's dive in.
Right, so let's talk about that precision problem for a sec. Look, calipers are great for a lot of things, but they just can't get a truly dead-on reading deep inside a bore. It's so easy to be off by a few thousandths, and in the world of engine building, that's not just a small error. That's the difference between a perfectly running engine and a very, very expensive paperweight.
And this is where the bore gauge comes in to save the day. It is an incredibly accurate tool, and you know what? It doesn't have a crazy high price tag. A single kit can cover a massive range of sizes, which honestly makes it one of the most valuable tools you can have in your box if you're serious about precision.
I get it. You open that case for the first time and it looks kind of intimidating. You see all these little parts, but don't worry, it's really just three main components working together. Once we break them down, the whole thing is going to click into place. I promise.
Okay, first up, we've got the indicator. This is the brain of the whole operation. The needle on this dial is so sensitive, it's designed to show you the absolute tiniest changes in the bore's diameter. And see that outer collar? You can loosen that to spin the whole face, which is absolutely crucial for when we calibrate it later on. Next is the housing and the plunger. Think of this as the heart of the tool. It's a pretty simple spring-loaded mechanism. As the plunger gets pushed in by the wall of the bore, it physically moves the needle on the indicator. Push the plunger, the needle moves. It's that direct.
And finally, we have the anvils and washers. These little guys are the key to the tool's versatility. They're basically just interchangeable rods that let you set up the gauge for pretty much any size bore you're ever going to measure. You just pick the right anvil, maybe add a washer or two, and you customize the tool for the exact job you're doing.
All right, now that we know all the players, it's time to actually put this thing together for our specific task. And the best part is, this isn't guesswork. Your kit comes with a little cheat sheet, a chart, that tells you exactly which pieces you need to grab.
Let's walk through this with a real number. Let's say our target is 1.7767 inches. You'll grab the chart from your kit, find the little row that includes that number, and boom, the chart tells you exactly which anvil to use. In this case, it's the number 3 anvil. It also tells us we don't need any washers. So you just screw it in, make it snug, and you're ready for the next step. Simple as that. And here is a piece of hard-won advice that every machinist knows. These kits have a ton of tiny, absolutely critical parts. Stay organized. Seriously, losing one little washer can bring your entire project to a screeching halt until you can find a replacement. Okay, everybody, lean in, because this right here is the single most important concept to get your head around. A bore gauge does not tell you the absolute size of a hole. It's a comparative tool. It only tells you how different a hole is from a perfect target size. So the first thing we have to do is teach our gauge what perfect looks like.
We're sticking with our target dimension, 1.7767 inches. This is our North Star, our ground zero. Every single measurement we take from here on out is going to be compared directly to this exact number.
To set that standard, we need a tool we already trust, a calibrated micrometer. You're going to carefully dial it to our target, 1.7767. Now this is important. Use the little ratchet stop at the end to apply a nice, consistent, light pressure. Then lock it down. This micrometer now physically represents our perfect dimension. Now we zero the gauge. You take your assembled bore gauge and place it right between the anvils of your locked micrometer. Then you gently rock it back and forth. You'll see the needle on the dial sweep, hit a low point, and then start to move back the other way. That exact point of reversal, that's the true diameter. Right there, at that moment, you physically turn the outer ring of the dial until the needle is pointing perfectly at 0. You've just taught the gauge what 1.7767 inches feels like.
All right, deep breaths. The tool is assembled, it's calibrated, it knows what perfect is. Now for the moment of truth. Let's actually go measure our cylinder bore. This part takes a little bit of feel, but the technique itself is pretty simple.
And this really captures the whole technique. Just like we did in the micrometer, our goal is to find that minimum reading by sweeping the gauge inside the bore. That single point where the needle stops going one way and reverses, that's your measurement.
So, you'll slide the gauge into the bore and get it pretty straight. Keep one side pressed firmly but gently against the cylinder wall, and then just rock or sweep the other side back and forth. As you do this, keep your eyes glued to that dial. The needle will sweep, it'll slow down, it'll stop, and then it'll reverse. That point of reversal is the number you are looking for.
Okay, you did this sweep, the needle landed on a number. So, what does that actually mean? This is where a lot of people get tripped up, but it's really simple once you know the secret. Now, this is the one part that feels totally backwards at first, but trust me, it'll make sense. When the plunger gets pushed in further, which happens in a smaller hole, the needle moves clockwise towards a positive number. So just burn this into your brain. Clockwise means smaller. Say with me. Clockwise means smaller. This chart breaks it down perfectly. If your needle lands on 0, awesome. Your bore is exactly the target size. If it lands on a positive 2 plus 2, that means the bore is 2/10,000ths of an inch smaller than your target. And if it lands on a -2, -2 going counterclockwise, it means the bore is 2/10,000ths of an inch larger than your target. See? Simple.
But a single measurement doesn't tell the whole story. If you want to do this like a pro, you need to check for any imperfections. Take readings at the top, middle, and bottom of the bore. That checks for taper. Then, rotate the gauge 90 degrees and do the whole thing again. That's how you'll find out if the cylinder is out of round. If it's more of an oval than a perfect circle.
So, if you walk away with just one thing today, please let it be this. A bore gauge is a comparator. It's playing a game of hot or cold, telling you exactly how far away you are from that perfect 0 you said earlier. It doesn't give you a measurement, it gives you the difference. That's its superpower.
And there you have it. You now have the fundamental knowledge to use one of the most powerful and important tools in precision work. Of course, like any skill, the key now is practice. So get out there in the shop, start measuring, and get a feel for the tool. We'd love to hear what project you're going to tackle first.